Hello everyone, I am Palma and I am a creator and a physicist. I live in a very small town in the south of Spain, right by the Alcornocales Natural Park. Here, I don't have access to laboratories or universities, but I create solutions to problems that arise in my communities.
One of the projects that I am leading here is Verdra. There is a fungus here with no treatment that is spreading across forests all over the world and is killing centuries-old trees within a week. It is not only destroying the habitat of thousands of species, but also the rural economy that depends on the forest, such as cork, honey, and Iberian pigs. Verdra is an autonomous drone and biosensing system to detect Phytophthora cinnamomii in forest soils before trees show symptoms. An AI first maps infection risk using satellite data on humidity, terrain, and livestock movement. Each night, drones are deployed to collect and analyze soil samples using LAMP PCR microreactors, which detect fungal DNA fragments and immediately send the info to the AI, which prepares a report for agronomist engineers who will clean the surrounding area where the fungi was detected.
Hola, buenos días. Mi nombre es Sergio Delgado, soy ingeniero de monte a través de la Universidad de Córdoba y nos encontramos pues con un árbol, un alcornoque pues afectado por la seca, principalmente por el daño que produce Phytophthora cinnamomii. Y quiero valorar el proyecto que se está llevando a cabo para intentar de mitigar y de intentar de prevenir que estas situaciones pues no ocurran y al final consigamos que el parque mantenga lo que es su nombre, el Parque Natural Los Alcornocales.
This project was one of 30 selected among thousands and was fully funded by the Villars Foundation in Switzerland. And we even received a purchase offer from a private company, but I refused, since this is a social, not a commercial project.
What you can see right behind me is the Alcornocales Natural Park, and this right here is another centenary tree. Thank you very much for watching and supporting this project.
Another problem I'm working to solve is that of wildfires. Spain was burning this past summer. I observed a wildfire map of Spain, thousands of red points spreading across the landscape. Each point was not just a fire, but families losing their homes, ecosystem collapsing, and firefighters risking their lives with tools that in many cases have barely evolved in decades. That's why I designed WildfiresAI, not to replace firefighters, but to think alongside them. It is a human-in-the-loop artificial intelligence system to support faster, more precise wildfire mitigation. The system integrates environmental data for more than 30 satellite and geospatial sources. These data streams are fused to estimate ignition risk, fire spread dynamics, and local containment constraints. It was hard to find a mentor to guide me, but finally Dr. Alireza from MIT got interested in the project, and every Thursday afternoon we meet online. Apart from the prediction of wildfires, WildfiresAI addresses a less explored question. Which materials are optimal for containment under specific fire conditions? For this, the system connects to the Materials Project, a materials database developed by the Lawrence Berkeley National Laboratory. This allows the system to analyze properties such as the thermal stability, degradation temperature, density, and chemical robustness. At its core, WildfiresAI operates through a structured, multi-agent pipeline. Agent A interprets firefighter input, translating real-world language into scientifically actionable queries. Agent B receives verified materials data from the Materials Project using a strict, predefined filters. Agent C then performs quantitative analysis. It evaluates the stability, applicability, and trade-offs, and produces a very structured and auditable output. Finally, Agent D executes real code to generate visualization and deployment-ready summaries. It ensures full traceability from input to recommendation. It is important to note that firefighters remain a central part of the system. After interviewing firefighters in Spain, France, and the US, I realized that the most important piece when extinguishing a wildfire is a firefighter's intuition, and I could not ignore that. So, I made sure that WildfiresAI supported human-machine direct communication and collaboration. A firefighter or technician can input a specific prompt for local conditions, such as terrain, wind shifts, fuel type, or a material query, and they will receive personalized containment and material recommendations. The long-term vision of WildfiresAI is to achieve physical deployment, which means having the information of these fire-extinguishing materials sent to a physical developer, and have the materials be developed by the AI at the firefighter stations. In the end, Wildfires AI is built to reduce response time and ultimately protect lives, to keep fighting for what can still be saved.